Learning Arduino with Fritzing Starter Kit by and with Stefan Hermann. Today we want to talk about breadboard prototyping, and we will build the circuit which I call flip-flop. Okay, let's change to the Fritzing software to explain what's going on. If we take a look here into our first example, then we simply placed an LED on this digital pin 13. That was quite easy because we could just attach the LED to the Arduino board. But usually we can't place an LED directly into a pins of the Arduino because each pin supports 5 volt. If we set a pin to high, then it means that here are 5 volts on there, and an LED can't deal 5 volts. It only runs from 2 to 3 volts or something in that way. But on the pin 13 there is a built-in resistor which protects the LED. So if we would like to run an LED on a different channel, then we would need a resistor. But unfortunately it's not so handy to have an LED here placed to somewhere and maybe a resistor here and to connect this and that directly and this resistor somewhere here, right? This won't be too handy. Therefore we have something to place electronical components, and it is called a breadboard. So you find it in the Fritzing starter kit and you can buy it everywhere you want to. A breadboard is something like a solderless connection board, and each of these pins are connected in a special way, each of these holes in this breadboard. So at first we have here these little columns and they are connected. If I press it here, then you can see everything what is yellow is connected. So here it is, the pins in the middle are all connected in columns. Okay, so if I place a part here in this hole and another part in that hole, then both parts are connected here. The outer rows are connected, like you can see here. Everything what is highlighted in yellow now is connected. These little rows are usually used as the power connection, or usually we stick in the power here, and it's up to you how to do that. My recommendation is, if you have a breadboard like that, it would mean that here is a gap in there, and my strong recommendation is now take some of your wiring set wires and place some wires here and there and here and there. And as long you are in this beginner state of learning Arduino, please just keep these wires in there. You will have you will just kill a failure source with that, because it's very often like people connect something here and connect the power supplies here, and then they connect their parts in here to this power rows, but there is still this gap and no power will run through, and they are searching for this error for so long time and don't know what's going on. So I will just say place these little connections in there, it won't hurt, leave them in there, and everything's perfect. So, but back to our main topic. I will zoom a little bit in that you can better see what's going on. So this little flip-flop example there, I will take 2 LEDs Let's, for example, take a red one and maybe a yellow one, right? Or it's up to you, whatever you want. I take maybe green. Okay, so again we have the long leg, what will be the plus, and we have the short leg, what will be the ground. So on the Arduino board here is a ground pin. I connect this to my Arduino, and I will change the color that you can simply see what happens here, or I can just drag everything over there. So black always means ground if I'm drawing something, therefore I maybe can change this here too. It's on a breadboard, unfortunately not so easy. Now I can connect each ground of the LEDs to this ground signal. So this here and this there. So every LED now is supplied by this ground. So if I click this wire, then everything what's highlighted is connected. And now I said that it is needed to place a resistor to this LED. Therefore I use a resistor. Each resistor has his own value. This one is, for example, 220 ohms. All the time you have 5 volt and you would like to place a resistor for a standard LED, just take 220 ohms and it will work perfect. There is a way to calculate all the resistances you need, but as long as it's so easy, you can just grab this 220 ohm resistor and it will work fine for you. And I place it here to this LED, or maybe I make a little bit more space for that LED that you can better see what's going on. Here the power now goes to this plus and through this resistor, right? So both parts here are connected on that long leg of the LED. And the other side of the resistor, I will attach it to the digital pin 11. And the other LED again needs a resistor, which comes here, and I will connect it to the digital pin 10. Right, let's make it a little bit nicer. All right, so let's go to the schematics. So this drawing is called the schematics, and engineers are using this to read circuits, and I'm sure you maybe remember when you were at school, then this is how electronics is taught. And it often makes things much clearer, so I will just show you what is going on, so that it's easy for us to see. So here we have our circuit. Both LEDs are connected to the ground over that wire, that connection, and each LED has got a resistor before the digital pin comes. So, and this resistor is protecting the LED from a too high current. Yeah, and that's actually all, quite easy. And here this could be the code, for example. So we have a little, or we have two variables, LED pin 1 and LED pin 2. LED pin 1 is 10 and LED pin 2 is 11. And we have to tell Arduino that we have this both pins, which are both outputs. And here we have our loop, which is actually like the blink, but the first time the first LED blinks and the second not, and in the second the first LED is not lighten up, but the second is. So it's a flip-flop, isn't it? Okay. So let's see how it looks in the real world. Therefore, I will rebuild this original circuit. So here we have our breadboard, and I took out this LED. And I will, of course, need some wires. So they are shipped with the starter kit too. Right. So hope you can see that. Now I take, as I said, the wires to bridge these connections. They are not so needed by now, but again, I just recommend that you just prepare your breadboard like that and close this gap. It's only the one gap in the middle, so everything else, everywhere else will be connected. So here is a connection, and here and here and here. Only here where this W is, there is no connection. There are other types of breadboards which don't have this gap, but here it is on. So now I have my first LED, the red one, and I place it like I showed you on fritzing here. And I have the second LED I will place here. Now I need some resistors, and here I have to take a look. This is red. Red brown means that this is 220 ohms. In the starter kit you can even find a drawing how you can see what a resistor is, or what value the resistor has. So here I have these two resistors I will need, 220 ohms, and I will connect them here and there. That's maybe a little bit hard to see, right? And I think it was a green one, wasn't it? Here, and now there comes my second resistor from here to there. And I need the ground connections I was talking about. So this will be this wire here to the red LED and to the ground of the second LED. By the way, the ground on an LED is called the cathode, and the plus leg is called the anode. Alright, so now I need the connections to my Arduino board. And the one was the ground, which is here. And now I said it's number 10 and number 11. Okay, I'm done so far. What I need now is programming code. So my programming code is here, and I uploaded it to the Arduino board. So that's a flip-flop, isn't it? Okay. This episode was brought to you by fritzing.org, the free and open software for project documentation, sharing and PCB layout creation. Check out our PCB fabrication service Fritzing Fab. With the purchase of Fritzing products, you actively support the development of the Fritzing software. For more Arduino related questions, go to arduino.cc/forum. watching.